You're still hearing me. All right, let's go to number 3. Okay, this is a 5th degree because I have f of x equals x to the 5th minus 2x to the 4th minus 12x to the 3rd minus 12x squared minus 13x minus 10. We're going to have to depress this down a couple times. We have to get down to x squared, which means I need to depress this 3 times. This is a degree of 5. That means we have 5 solutions. So let's look into our graphing calculator. When I look at my graphing calculator, I find 3 solutions. X equals 5, -1, and -2. There's 3 of my solutions. So that's good because we need to depress it 3 times. And this will work every time. If we're looking for imaginary, we'll get down to x squared. Okay? So let's do this. Let's start with one of them. I'm going to start with 5. You could start with any of them and it would work. It doesn't matter which solution you start with. That's just what I started with in my notes, so I want to keep to it. We make sure we go 5, 4, 3, 2, 1. I'm looking at the exponents on my x's. No placeholders are necessary. My coefficients are 1, -2, -12, -12, -13, and -10. Bring down. 5 times 1 is 5. -2 and 5 is 3. 5 times 3 is -15. That's wrong. 5 times 3 is +15. This is where you got to be really careful. I make mistakes on these because if you start going too fast and you mess it up, you got to start over. 3 times 5 is again +15. That brings down a 3. Again, +15, but this time we bring down a +2. And again, it should be 0 if this works. And this is 10. Whew, it worked. We depressed it once. Now here's a shortcut. I don't need to rewrite. I'm going to use these same numbers. We're going to use the depressed polynomial, but we don't really need to write out the polynomial. So I'm going to go to my next solution, and my next solution is -1, and I'm going to use that to depress it further. Let me make this a little narrower. Okay, so we're going to depress that further. So we're just going to use those numbers again, and we're going to depress it down again. Okay, bring down the 1. -1 times 1 is -1. That gives me 2. -1 times 2 is -2. That gives me 1. -1 times 1 is -1. That gives me 2. And again, this should result in a 0, right? -1 times 2, -2, 0. So we've depressed it down again. So we've depressed down twice. We're still not far enough because we need to get all the way down to x squared. Well, if we depress it once from the 5th, we're down to x to the 4th. We depress it a second time, we're down x to the 3rd. We need to depress it one more time. So I come back here and I use my -2. I'm going to use my -2 here, and we're going to depress it one more time. So 1 times -2 is -2, gives me a 0. -2 times 0 gives me 0. 1. -2 times 1 is -2, 0. Now we're down to x squared. So remember, we depressed it 3 times. So we went x to the 5th, depressed once. Now we're x to the, here's our, this is really, at this level right here, we're now at x to the 4th. We depress it again. Here's my x to the 3rd polynomial. And then now we're at x squared. So we can write 1x squared. There's no x. This is 0x. Plus 1. And now we're going to figure out this one. Now that we're down to x squared, we have our 3 choices. We can factor and solve. We can complete the square. Or we could use quadratic formula. Well, before I do that, I'm going to simplify. This is really x squared plus 1. I don't even have to use one of those choices. I can just solve it. So I'm going to subtract 1 from both sides. X squared equals -1. I'm going to square root both sides. Remember, square rooting results in 2 answers. X equals, well, what's the square root of -1? It's I, so plus or minus I. What are my 5 solutions then? Well, we figured out from the beginning. 5 was the solution, -1 was the solution, -2 was the solution, and then I have I and -I. There's my 5 solutions. Okay, let's do number 4. Number 4, find all the zeros for r of x equals x to the 4th minus 6x to the third plus 12x. I'm actually, as I'm doing this, I'm checking to see if I need any placeholders. I can kind of do that quickly now. So I have 4, 3, 2 plus 6x minus 13. I don't need any placeholders. I put this into my graphing calculator. I have to depress this twice. Okay, so again, when I look at my graphing calculator, I have a negative answer, a positive answer, which results in 2 imaginary answers. I need 4 answers altogether. I need 4 solutions, 4 roots, 4 zeros. Okay, so when I did this in my graphing calculator, I noticed my 2 solutions were x equals, or across the x-axis, at -1 and +1. That means I have a negative answer, a positive answer. That means I'm looking for 2 imaginaries. So I need to depress this equation twice. It doesn't matter which one you start with. I happen to start with -1. So my coefficients are 1, -6, 12, 6, and -13. Bring down the 1, -1, -7, 7, 19, -19, -13, +13, good, resulted in 0. Again, I'm not going to, we're now down to x to the third, but I need to depress it one more time. We know our other solution is 1, so I'm going to use synthetic division with that. So now we've depressed it twice. We're now to our x squared. So x squared minus 6x plus 13 equals 0. Couple choices here. I could factor. It's not factorable, so that's not really a choice. I can complete the square. I'm going to complete the square because my lead coefficient is 1 and b is even. If that wasn't the case, I'd use quadratic formula. So I subtract 13 from both sides. So I have x squared minus 6x plus a box equals -13 plus a box. Half b square it, put it in the boxes, so 9 goes in the boxes. This is a perfect square, so this is x minus 3 squared. If I were to FOIL x minus 3 times x minus 3, it would give me back this. So I haven't lost anything, I just factored it. And then over here I have -4. Square root both sides. Remember, that gives you a plus minus. So that's x minus 3 equals a plus minus root -1 and then a 2 times 2. So what can come out? An I and a 2. So I have a plus minus 2i equals x minus 3. I add 3 to both sides. And so now I have x equals 3 plus or minus 2i. My solutions, x equals -1 and 1 from the graphing calculator. And then from all my work, I have 3 plus 2i and 3 minus 2i. Okay? That's all I'm going to do.